Imagine a world where machines understand us just as well as our fellow humans. Is it a distant dream or a fast-approaching reality? In this fascinating future, we find ourselves in a conversation with our devices, not just giving commands, but having meaningful interactions. This is a world where natural language processing, or NLP, has reached its pinnacle. But what does that mean, and why should we care? NLP, at its core, is a field of artificial intelligence that allows machines to understand, interpret, and generate human language. It's the magic behind your virtual assistant understanding your request to play your favorite song, your email service predicting what you're about to type next, or your social media platform translating a foreign language post into your native language. In a world where NLP has reached its peak, machines would understand not just the words we say or type, but the context behind them, the emotions they carry, and the nuances that make human language so complex and rich. This could revolutionize everything from customer service to healthcare, making interactions more efficient, personalized, and human-like. Imagine a customer service chatbot that doesn't just give generic responses but understands your frustration and works to alleviate it. Or a healthcare app that can detect signs of mental health issues from your speech or text patterns and offers timely help. But this future isn't without its challenges. As machines get better at understanding us, issues of privacy and security become even more critical. How do we ensure our conversations with machines remain confidential? How do we prevent the misuse of this technology? And then there's the question of jobs. As machines take over tasks that were once human domain, what happens to those jobs? While new technologies often create new jobs as they eliminate old ones, the transition can be difficult for those caught in the crossfire. To understand where we are headed, we should take a look at where we have been. As we delve into the past, present, and future of NLP, we'll explore these questions and more, uncovering the potential of this exciting field and its implications for our lives and our society. The journey of NLP began in the 1950s with the birth of artificial intelligence. This period marked the advent of an era where machines were envisioned to rise beyond simple calculations and data storage. The thought of a machine understanding and responding to human language was a captivating prospect. In this era of early exploration, the 1950s and 1960s, researchers began to experiment with machine translation. The idea was straightforward: convert text from one language to another using a computer. But as they soon discovered, language is far more complex than a simple code to be cracked. It's a living, evolving entity filled with nuances and subtleties that cannot be easily mapped out. Then came the 1960s and 1970s, which brought two significant developments in the field of NLP: ELIZA and Sherdlu. ELIZA, developed at MIT by Joseph Weizenbaum, was an early attempt at creating a chatbot. It could mimic conversation by recognizing keywords and generating predetermined responses. Meanwhile, Sherdlu, also hailing from MIT, was a system that could understand and respond to instructions in a simple artificial language. As we moved into the 1980s, computational linguistics began to emerge as a discipline. This field sought to understand language from a computational perspective, creating algorithms to analyze and generate human language. However, these early efforts were often limited by the sheer complexity of language and the computational power available at the time. These milestones were significant, but they also highlighted the immense challenge of NLP. Understanding human language isn't just about understanding words and grammar, it's about understanding context, sentiment, and the subtle nuances that make human communication so rich and complex. Despite these initial steps, it was clear that creating a machine with a deep understanding of human language was no easy task. The 1990s brought about a new era in NLP, with the rise of statistical methods. With the turn of the decade, the field of natural language processing, or NLP, started to experience a significant shift. The traditionally favored rule-based systems, which were painstakingly crafted and fine-tuned by experts, started to give way to a new breed of statistical methods. These statistical methods were revolutionary. They didn't rely on preset rules or explicit programming. Instead, they learned from data, picking up on patterns and nuances that would be impossible to manually code. This approach gave rise to machine learning, a subset of artificial intelligence that would come to redefine NLP. One of the key developments during this period was IBM's Watson. Watson wasn't just a machine learning model, it was a pioneering experiment in the field of NLP. Its ability to comprehend and respond to natural language questions posed by the participants of Jeopardy was nothing short of groundbreaking. This was a testament to the power of statistical methods in NLP. Simultaneously, Google was incorporating statistical methods into its search algorithms. By analyzing the frequency and context of words on a web page, Google could deliver more relevant search results. This was a major step forward in making information on the internet more accessible and useful. Around the same time, we also saw the advent of speech recognition technology. Systems like Dragon Naturally Speaking started to translate spoken words into written text with remarkable accuracy. This was a game changer, making technology more accessible and opening up new possibilities for human-computer interaction. All these developments were fueled by two things: big data and machine learning. The explosion of digital data provided a rich training ground for machine learning models. At the same time, advances in machine learning algorithms allowed us to extract meaningful insights from this data. The emergence of big data and machine learning had set the stage for a revolution in NLP. The 2010s marked the dawn of the deep learning revolution in natural language processing. This era was characterized by the implementation of deep learning and neural networks, which dramatically changed the landscape of NLP. Deep learning, an advanced form of machine learning, constructs artificial neural networks to mimic the human brain. This capability allows machines to process and interpret complex human language more effectively than ever before. A major breakthrough in this era was the development of Word2Vec in 2013. Word2Vec, a group of models created by Google, transformed the way words were represented. Instead of treating words as isolated units, Word2Vec represented words as vectors in high-dimensional space, capturing contextual relationships between words. This meant that words with similar meanings were positioned closer together, a leap forward in understanding the semantics of language. As the decade progressed, we saw the rise of transformer models. Unlike their predecessors, transformer models could process words in any order, making them highly efficient at understanding context. One of the most influential transformer models was BERT, short for bidirectional encoder representations from transformers. BERT's ability to analyze sentences in both directions was a game changer, enabling a deeper understanding of the nuances of language. Deep learning also brought about significant advancements in machine translation and sentiment analysis. Machine translation improved dramatically, with systems like Google's Neural Machine Translation providing translations that were almost as accurate as human translations. Sentiment analysis, the process of determining the emotional tone behind words, also became more nuanced, with machines able to detect irony and sarcasm, tasks that were previously thought to be exclusive to humans. The age of deep learning also saw the rise of more advanced NLP applications. Chatbots became more conversational, voice assistants more understanding, and text analysis more insightful. This era was truly a turning point in the field of NLP. These advancements brought us closer than ever to realizing the dream of machines that truly understand human language. So, what does the future hold for NLP? As we journey forward, we're likely to see a number of advancements that could redefine the landscape of natural language processing. One of the most promising areas is the improvement in contextual understanding. Currently, NLP systems can understand the meaning of words and, to an extent, sentences. But the subtleties of human language, such as sarcasm, humor, and cultural references, still remain a challenge. In the future, we can expect NLP systems to grasp these nuances more accurately, creating a more human-like interaction. Another field ripe for exploration is the rise of unsupervised learning. Today, a lot of NLP relies on supervised learning, where systems are trained on labeled data. But what if we could create systems that learn from unlabeled data, much like how a child learns a language? Unsupervised learning could unlock new levels of understanding and efficiency, and it's an area where we're likely to see significant progress. But it's not just about understanding text or speech. We're also likely to see advancements in areas like emotion detection and sarcasm recognition. Emotion detection has the potential to revolutionize industries like customer service, where understanding a customer's mood can make interactions more effective. And sarcasm recognition? Well, it's not just about making our voice assistants understand our dry humor. It can help in areas like social media analysis, where understanding sarcasm can provide a more accurate picture of public sentiment. The future of NLP also holds the promise of more inclusive language processing. As we develop more sophisticated models, we can expect them to understand and process a wider range of languages and dialects, not just the dominant ones. This can help bridge the communication gap across different cultures and societies. In essence, the future of NLP is a thrilling prospect. It holds the promise of more intuitive, responsive, and understanding machines, but it also presents challenges and questions regarding the ethical use of this technology. As we continue to push the boundaries of what's possible, one thing is clear: the future of NLP is as exciting as it is unpredictable. Today, we've journeyed through the history of natural language processing, from its early beginnings to its promising future. We've seen how this technology transitioned from rule-based systems to statistical models, and then to the current era of deep learning. The future of NLP holds immense potential, with applications in numerous sectors like healthcare, education, and business. The question remains, how will the continued evolution of NLP shape our world? Only time will tell. Thank you for joining us on this exploration of the past, present, and future of natural language processing.